Welcome, everybody. All right, so we all know Spanning Tree. We love to hate Spanning Tree or hate to love Spanning Tree. It's a necessary evil at the moment, which will be going away soon enough, hopefully, because we'll be doing routing at the distribution access layer. But for the time being, we need to improve our Spanning Tree. We need to put in safeguards that to make sure that we don't lose our root bridge, that we're getting messages back and forth, all these different things that these features that Spanning Tree has to improve its stability. So let me show you the topology that we're going to work on here. So, and I already have it labeled out and it's already configured. I'm going to show it to you. All right. And where do you go? Now, this particular, I'll show you the iOS as well, because based on the iOS, its commands will change. But anyway, so here we have our, this is one thing I haven't done is a Spanning Tree. This is the root bridge regardless. But this is the root bridge. This will be the secondary root bridge. And what's going to happen, this port here, it's going to be blocked. It's going to be blocked. So the reason I have this switch here is, I'm going to put my face back in here. The reason that I have that switch is because just that, people, and there's a reason why we need to do things like this, because people just buy switches and plug them in, right? And they just don't care what's going to happen. And you create loops. And the whole point of Spanning Tree is to prevent loops. So that's why you see the different root guards and loop guards and all these things. Uplink fast. And we'll talk a little bit about uplink fast. Be careful how you're going to use it, because you can't put it, it's only on access layer switches. Uplink fast is only on access layer switches because it bumps up the priority number, so that switch will never be the root bridge because of its priority number. But we'll look at that. I just wanted to mention that. All right, so let's take a look at the labels. So I'm going to put a root guard here, right? Because this switch that somebody plugged in there, I never want that to be ever a root port, right? I don't want it to be I don't want this to take the role, this switch to take the role of the primary root bridge. So we put root guard in there to protect the root bridge. Obviously, loop guard speaks for itself, right? We're preventing loops, even though this is blocked, but if something happens, it prevents it. And then EPU guard, we've used it a million times. All that's going to do is set the nodes down here where they can get into the designated forwarding state quickly. And you see UDLD over here. And let's go into the PDF that I have. Okay, so UDLD, it's unidirectional link detection, provides a means to detect a link that is transmitting one direction, enabling you to prevent bridging loops and traffic black holes that are not normally detected or prevented by STP. All right, it works in two modes: normal mode and aggressive mode. Normal mode basically is right here, says detect unidirectional links are detected and report as an error, but no action is taken. With aggressive mode, is reported as an error, right? And it's disabled after 8 attempts, once a second for 8 seconds to reestablish the link. Disabled ports must be manually re-enabled. All right, and then we will see the loop guard here, what it does, and it's kind of confusing sometimes when you're reading this, because the commands are not loop guard, they're not root guard, they're guard root, guard loop. So it's kind of backwards, but that's okay. So let's go ahead and configure. Let me make this the primary root bridge first. It is already, and I'll show it to you. Show Spanning Tree. Okay. Ooh, it's running slow. You can see it right here, right off the bat. You see all the ports are designated forwarding, but it tells you right here, this is the root bridge. It is the primary. I did turn it. Okay, so I did put it in primary. All right, so this is the primary root bridge. And remember, it is done through your default values, these allowed values. Then they add the VLAN 1, because I'm only running VLAN 1, and then it just adds it. That's how you get that. So this is the primary root bridge. Therefore, this should be the secondary root bridge right here. And let's verify that. Let's go to switch 2, enable. Show spanning tree. All right, and oh, I'm looking at this, but I clicked on switch to. Sorry. But since we're here, this is not the secondary. I'm literally here instead of here. My eyes went here, but I clicked here. So here's your root bridge. Now see what uplink fast does. Okay, and you can see here. I think I could do it up here. That doesn't really matter. I can show you. I'll show you because it turns that priority. And let me give you an idea what that priority number is. Okay. So I'm gonna pretend that I'm gonna set a priority number for span tree, VLAN 1, just to show you that number, VLAN 1. And now I'll just put a willy-nilly number in there. Oh, sorry. VLAN 1, priority 5, which doesn't exist. So it gave it a value right in here, 49,152, 49,152. So it's a pretty high value. What uplink fast does. Okay, it's a pretty high value, but you gotta be careful when you're doing it. So when you do it, you're gonna do spanning tree. Yes. All right, and you see it right there, uplink fast. Okay, uplink fast, and enables the uplink fast feature. Very good definition there. Uplink fast. And then you could put a max update rate if you wanted to, how quickly it'll come up, right? Because it's used for in case one goes down, then if a link goes down, it'll come right back up quickly, all right, to prevent any downtime. But one of the things that it does do that you got to be very careful with the uplink that you cannot do it. You cannot do it in the root bridge is that command, the uplink fast command. You cannot do it in the root bridge. Basically, uplink fast provides it's just fast convergence, basically, and you can tweak, as you see here, in the maximum number of updates per packet. But it's there for fast convergence, okay, in case the span tree topology changes, what have you, if you're using uplink groups. But it's a failover, basically. It's a failover. So, but again, do not do this command on your root bridge. Do them on your non-root bridges. I'll say it that way, non-root bridges. All right, so let's go now actually to the secondary root bridge. Show spanning tree. And you can tell this is a secondary root bridge because it has this 2862, which is the default value, and it added 1 to it, giving you this. And these ports, you have a root port right here, which is this one, going to the root bridge. And all the other ports are designated forwarding, okay? Designated forwarding. Now here, and I'm going to show you the loop guard in a second, but here is where in both ports, here and here, I would use the BPDU guard, right? So let's go to switch 3, because I haven't done that. Switch 3 and go to port G00, config T. We all know what this is, conf T. And this is one of the things that you should do. So you can not only, when you plug in your PC, it goes right away to designated forwarding. But if you do that and you tell spanning tree not to look at it, you have to do the spanning tree BPDU guard enable as well. All right, so let's go to interface, just one port, G0/0. So what we need to do is port fast, first of all. Oh, sorry, spanning tree, port fast, okay. All right, so that gives you a warning, and that's where you do the BPDU guard, all right, because you don't want nobody plugging in a switch there, and all of a sudden you start getting BPDUs, and it creates a loop. So you do a BPDU, spanning tree, once again, spanning tree, BPDU guard, enable, okay? So that is definitely something you want to do. So when you plug it in, any PC, and the packet tracer is pretty cool because you see the little light, all right, how quickly you do it. It goes into designated forwarding. But spanning tree now is not looking at this port. It's not looking at this port. So, but because we turned off spanning tree port fast, But since we're using the BPDU guard enable, it's guarding against anybody plugging in. Let's say this PC goes down, or you take off this PC and you plug in a switch trying to be slick. It's going to become an ER disable port, which you're going to have to bring up manually. You have to bring up manually. So you saw the uplink fast, all right? You've done in global configuration. You can do it here. You can do it here. Doesn't matter. I mean, well, if that's what you want to do, then do it. The loop guard, it's the other one. Let me show you those commands. I'll do it right here in switch 2 because this is the port that's blocked. And if you go to port or switch 2, sorry, so span tree. Okay, there's our block port right there. Okay, so we're going to go into config T and we're going to go interface G0/1 and we're going to do span tree. And now here you have BPDU filter, BPDU guard, cost, and then you see the command guard, this guy right here. Okay, so what do? You type in guard, and then here's where you have the loop, none, and then root. So I did root on G13 because that's a switch. I don't want ever that switch to take away the actual root bridge, right? So I'm guarding against that. So root, you can put guard root, or in this case, guard loop. And like I did already, guard loop on G01 interface, and there's nothing else after that. There's nothing else. So it's going to guard against those particular loops. And if you look at the guy right here, STP loop guard, which we just did, detects the absence of BPDUs on the root and alternate root ports. Non-designated ports are temporarily disabled, preventing them from becoming designated ports and moving it into a forwarding state. STP loop guard should be enabled on root and alternate root ports, both non-root designated for possible active STP topologies. So it's not going to kill anything. So I could put it here as well, just to guard it, guard from creating loops. Okay, so we got our loop guard, we got our root guard, or guard loop, guard root. Okay, that we do. And what's the other one? Oh, UDLD. All right, so let's back out. Now UDLD is its own command. There's no spanning tree in front of it or anything like that. It's its own command. And one of the things you can do when looking for this, you type the letter U and then you question mark right next to it. So it tells you all the commands are there. So UDLD is there, UDLD, right? And then you question mark. So you can do enable UDLD protocol in aggressive mode on fiber ports except or locally, but you can do it on twisted pair as well. Obviously, this is virtual, but and then message. So all you do, which I did already, but I'll do it again. So you just enable it. You enable it, and it's in global configuration. So you do it. All the switches, all 3 switches, I've already enabled with UDLD globally. You then can go into the port interface, because if not, when you debug, and we'll do a debug int interface G0/1, you're gonna do UDLD, right? What do you want to do? Port. Now you want to turn it to aggressive, because remember the definition. Put my face back in here. Remember the definition. The definition said that you have aggressive and what do I call it? Aggressive. You're the normal. So normal mode, well, you're not seeing it. Normal mode, they're detected and reported as an error, but no other action is taken, where aggressive mode is taken. So if you want to see some, some stuff in the debug, we go ahead and do the go into the port and put aggressive. Okay, so let's go in there and do that. All right, and I believe I already did. Let's do a debug. All right? If not, just put aggressive, and that's all you do. But let's show the full command. UDLD port aggressive. That's it. Now that's it for this iOS. Let's do a debug. All right, and we'll do it specifically for, where are we? We're on switch 2, and we'll do it for G02. So we're gonna do a debug, UDLD for gigabit G0/2. Yeah, let's hit enter. What? Oh, sorry. I was thinking something else. Events. I think I was thinking of the show command where you can do that. All right. So let's do a U all. Stop that. All right. So all you're seeing here says neighbor, advertise, and transmit intervals. Okay. Seconds or milliseconds. Neighbor, cache, expiration time. All right. Found an entry from the same device on G01. So very basic entries. Nothing's going on right now. So that's fine. You could also do show UDLD. What? No, okay, it's show DL, show UDLD, and then G0/2 was it? I believe. Yeah, there we go. And we can see things that you can see this in aggressive mode. Okay, it is enabled, but it's in aggressive mode, both of them. Here, current bidirectional state is bidirectional. That's what the state of the port is. Single neighbor detected because one's blocked. One's blocked. All right, but these right here, this is a virtual environment. So they only work on the actual physical environment. If you want to do a fast hello or port fast hello or neighbor fast hello, you have to be on the actual physical ports, not virtual ports or SVIs or anything like that. So that's why that's disabled right here. You're not going to be able to configure it. All right. And then you have entries here. All right. You can see the messages on UDLD. They remember when we typed in global configuration for messages, we can change the default value of 15 seconds if you wanted to. So if you come in here, config T, but if you do it on one, do it on all. Okay. And you can do UDLD message time, and then you can go ahead, but default is 15 seconds. All right, you can change it to whatever you want. Now, do you want to make it faster or do you want to make it slower? It's completely up to you. Your bandwidth that you're using, the type of cabling you're using, all that. How do you want that to happen? So you can change the UDLD message time period from the default 15 seconds. All right, you can do that. So all these things together, UDLD, first of all, first and foremost, selecting your root bridge, primary and secondary, then using UDLD. Okay, if it notices any problems, I'll go ahead and take care of it. And then you have the loop guards that you can do on both root and non-root ports. Okay, you have the root guard that's going to protect any, you plug in a switch, has a lower bridge ID. It may want to take the bridge ID from the root bridge. You prevent that from happening. Okay. The uplink fast only done on the access layer switches. Access layer switches, uplink fast. And normally I have dual links going up. I'm just have one. And then BPD guard, which is you're enabling that on ports that you've turned off spanning tree. And that's how you keep the stability of spanning tree. So that's why spanning tree, nobody likes it. And it's going away. Whether you're using spanning tree or you're using MST, multiple spanning tree, all that's going away. But if you're in a job environment, right, where you have to deal with spanning tree, these are steps that you should take, all right, to prevent loops. Or if you have multiple links, you want to be able to fail over quickly, all right? But remember that command, uplink fast, because it brings up your priority value to a very high number, all right? To a very high number. So that particular switch would never become the root bridge, okay? That's it. That's all there is to that. It's a little bit confusing, but as far as a lot of different commands that you got to do, but in anything, design is everything. And all your topologies, okay, in your topologies, the design of it is the most important thing. And that's why you need to say, okay, who's going to be the root bridge? Who's going to be the secondary? All right, so those are my two main switches. And this is the one that's blocked. Okay, so we need to now start protecting ports. All right, we need to create failovers. We need to prevent some switch that's being plugged in from becoming the root bridge. And we need to make sure that our hosts in our LAN, they're the ones that are going to go ahead and we disable spanning tree there, right? Spanning tree doesn't need to be looking at ports that your end devices are at. So we turn off spanning tree by doing spanning tree port fast. And as we did, and then we did spanning tree BPD guard enable, right? Under a port or a range of ports. It's going to be a range of ports, obviously, but you need to know this. Not only do you need to know this for your personal environment, but you need to know this for your certification exams, especially at the CCNP level. All right, you need to know this stuff. Okay, all right, that is improving the STP stability. All right, all these different types of commands. So try it out, get into it, practice it, and you'll be good to go, ready to go. See you in the next one.